Hello, Math Humans. We're going to do 3.5 today. We're going to be talking about counting methods. So our objectives are that we're going to look at tree diagrams, the multiplication principle, factorials, permutations, combinations, and then we're going to lastly talk about probabilities with combinations and permutations. So I'm going to kind of start off with a little example, and we're going to talk about a three-course dinner. Okay? Oops, spelled it wrong. So in our three-course dinner, we're going to have 4 salads, 3 entrees, not meaning that you're going to eat all of those, but these are going to be the things that you can choose from, 2 desserts, and I want to know how many different dinners can you have. Well, one way of managing this is in what's called a tree diagram, and they're kind of fun to do, but you'll see as we walk through this example that if we had a lot of choices, this would get to be really annoying. So let's say I'm going to start with salad 1, and then I have salad 2, and then I have salad 3. And then for each of those different salad choices, let's say I have the first entree, the second entree, and the third entree, and then I have that for each of my choices of salads, so E1, E2, E3, and then for my third, I had E1, E2, and E3. Well, then for the next course, this is my entree, now I have 2 desserts. So I have D1 and D2 for this choice, D1 and D2 for this one, D1, D2. I got a lot of D1, D2. You can see it gets to be, that's a D1, D2. Oops, I'm running out of room. D1, D2. Oop, here we go. D1, D2, D1, D2, D1, D2. And then if I said how many dinners, I would count my possibilities. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18. So there were 18 possible choices for dinner. Okay? Well, that gets to be quite laborious. And so a fun example to talk about, and I know I have a couple of humans that work at Subway, so let's talk about Subway. And I'll just illustrate what would happen if we tried to do the same process. So let's just say we're going to talk about sandwiches. Okay? And just by talking about sandwiches, and these are numbers that I made up, so let's say that there are 5 different types of bread that you can choose. There are maybe 10 different meats. For cheeses, maybe there are 4. And then we have to talk about our veggies, and then we have to talk about what condiments, meaning like your salad dressing, salt and pepper, whatever. And then we want to know if you want it toasted or not. And then we're going to talk about, do you want chips? And then, oops, I spelled cheese wrong. And then we're going to talk about cookies. So you can see if we had to do this for this many different options, that could be crazy. And so I'm going to go to the back of this page, and we're going to talk about the multiplication principle. So instead of drawing out all of the tree diagrams, we can multiply the choices together. So if we continue with our Subway example, so we said that we had 5 breads, 10 meats, 4 cheeses, 7 veggies, 5 condiments, 2 toasted, 5 chips, and 2 cookies. Well, if we do that math, if we multiply all of those numbers together, we would get that could potentially make 140,000 different sandwiches. And because I guessed at all of those numbers, my assumption is that this is significantly higher. All right. So that is the multiplication principle. It's a way of shortening our tree diagram. So now what we're going to do is move into our examples. So for example number 1, we have picture frames that we're going to put on a mantle. And there are 10 pictures, all of them have to go on the mantle. How many different ways can you arrange your photos? Well, this is the basic counting theory. And it is what we just talked about. It is the multiplication principle. Both of those things kind of mean the same thing. Different books call them different things. So when I choose to put the first picture frame on the mantle, I have 10 pictures to choose from. Well, then for the next picture, because I've already used one, now I have 9. Well, then on the next one, I would have 8, and then I would have 7, and 6, and 5, and 4, and 3, and 2, and that would be my last picture frame. Now, this is a unique situation because I have 10 times 9 times 8. These numbers are actually a math concept called 10 factorial, and I'll show you how to do that on your calculator in just a moment. 28,800. So if you were just talking about putting all 10 pictures, and so this would be my process. So when you have all of these numbers in descending order, multiplied together, it's 10 factorial, and you would have 3,628,800. So let me show you how to do that math in your calculator. You're going to do 10, and then you're going to use the math button. You're going to go to the right where it says probability, and you can see our cute little exclamation point right there. So now I have 10 factorial, and when I hit enter, I get 3,628,800. Alrighty, so that is how we would do that particular example and use our calculator to manage 10 factorial. For the second example, I'm actually just going to do it on paper. So for example number 2, I want to just experiment with some factorials. So if I have 5 factorial, that is 5 times 4 times 3 times 2 times 1. Again, I could do that in my calculator. I'll show you again. I'm going to do 5 math over to probability, option number 4 on my calculator, and enter, and I would get 120. Okay. If I did 8 factorial, which is 8, 7, 6, 5, 4, 3, 2, and 1, and I push buttons on my grapher, then I would get 40,320. Alrighty, for our next example, let me get another piece of paper. We're going to do problem number 3. And these are fun problems to do, and you'll see why. So Arizona license plates have 3 digits. They are 3 numbers followed by 3 letters, and it wants to know how many license plates if. So we're going to explore some different possibilities. So for A, it says that both letters and the digits can repeat. So the way that I do these is I draw out a blank line for each of my spaces. So here's my 3 numbers, and then I have 1, 2, 3 letters. So these are going to be my numbers, and then these are going to be my letters. Okay. So in the first one it says everything can repeat. So your numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 10 numbers. They can repeat, so that means I have 10, 10, and 10. And if I talk about my letters in the alphabet, and I go from A to Z, there are 26 letters in the alphabet. And since they can repeat, I have 26, 26, and 26. This is the multiplication principle, so all of those numbers are multiplied together. And if you do that, you're going to get 17,576,123, and these are going to be how many license plates we could have. That's a lot of license plates. But then you have to consider how many people do we have in the state of Arizona. So the next part of this example for B, it says the letters can repeat, but the digits can't. So again, I'm going to draw my 3 for the numbers, and then I'm going to draw 1, 2, 3 for my letters. Okay, so let's do the digits first. It says the digits can't repeat. So that means on the first option I have a 10. but I've already used 1, so now on the second one I have a 9, and now I've used 2, so now I have an 8. And then it says the letters can repeat, so this is 26, 26, and 26. And again, all of those numbers are multiplied together. And when you do this, you're going to get 12,654, 720 plates. Okay? So you can see by saying that the digits can't repeat, that reduces the number of plates that I have available. Okay? Option number C, okay, says the first digit can't be 0, and the rest of the letters and digits can repeat. So again, I'm going to do my 1, 2, 3, and then my 4, 5, 6. So the first digit can't be 0, so if we look back up here, now that means that I have 9 numbers to choose from. And it says everything can repeat, so I'm going to choose 10 and 10. And then it says these guys can repeat. Remember, all of those numbers are multiplied together, and this would be 15,818,400, and that would be the number of plates that are available. All right, I have one more of these, and this one says nothing can repeat. So again, here's my 3 for the numbers. Here are my 3 for the alphabet. So when I do my first number, I have 10 choices. I've used 1, 9 choices. I've used 2, 8 choices. And then on my alphabet, on the first letter, I have 26. On the second one, I've already used 1, so now I have 25. Third one, 24. All of those numbers are multiplied together, and this is going to be 11,232,000 plates. So that's actually kind of an interesting process. All right, so I'm going to turn this over while I do the next part. So for the next thing that we want to talk about are our permutations. The definition, and it is basically part of the multiplication principle. And again, we're going to be looking at how many ways can I arrange something. But in this one, this is a very important part. Order is important, which means that we're also going to talk about one where the order isn't important. Boy, I can't write this morning to save myself. So the order is important. So I'm going to show you what it technically looks like. So it's going to be a permutation of n things, and then chosen are ways. Okay? And technically, the formula for this is n factorial over n minus r factorial, but we have already talked about this, so I will be able to show you how to use your grapher, and I'll show you that in just a moment. So we are going to be able to use your grapher. You're not going to have to manage this individual formula. But the thing that's really important about a permutation is that the order is important. Okay? So now I'm going to move to example number 4. Let me get my blank piece of paper back. Okay, so in example number 4, it says I'm going to have 10 cars in a race. And then how many ways can 3 cars finish first, second, and third? So for me, if I'm talking about a permutation, I think about there's an award or a reward. And so that helps me to understand that the finishes are important. So here would be how we would write this. So I'm just going to show you once how to do it by hand because it's kind of cool. So I had 10 cars, and I'm going to choose 3 ways, first, second, and third. Technically, this would be 10 factorial over 10 minus 3 factorial. And I'm just going to show you what happens if you do it by hand. So I would do 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. That's the 10 factorial. This is going to be 7 factorial. And so this is 7, 6, 5, 4, 3, 2, 1. And if you'll notice, all of these guys cancel because they're multiplied together. So then your answer is going to be 9 times 8 is 72 times 10 is 720. So there's going to be 720 different arrangements. Okay? But now let me show you how to do it in your handy dandy calculator. So I'm going to have this open so you can see it. So to do a permutation, I'm going to enter how many things I have first, the 10, and then I'm going to do math, and then probability, and notice number 2 is your permutation, and then I have to enter how many ways I'm going to choose those things, and I hit enter, and there is your 720. Okay, and I'll show you again how to use your calculator on the next example. Alrighty, example number 5, as we're cruising right along, says we have a school orchestra that's planning to play 6 pieces of music at their concert. How many different programs are possible? So this is kind of a unique situation in that it's a permutation, and I have 6 things, but we're going to play all 6 songs, so technically it's the permutation of 6 choose 6. Well, this is actually going to be 720, and this is, I have kind of like our picture frame problem. Technically, it's 6 factorial. So when I do a permutation of how many things, and I choose all of those things, it's the same thing as doing a factorial. Okay? Alrighty. Another piece of notation that you'll see in this particular book is they would write a permutation as this way instead of this way. This is your calculator notation. It is always my preference, but you may see this in your book. So this is how many things, and the second number would be chosen are ways. So it's just another way of notating the same thing. All right, let's move on to example number 6 now. Okay, so in example number 6, we have a volunteer club that has 18 members. An election is held to choose a president, a vice president, and a secretary. In how many ways can the officers be chosen? So this would be one of the situations where I think this is an award or a reward, is that you are getting to help lead an organization. So I would think of this as a permutation. So this is going to be the permutation of 18 because I have 18 members, and I'm going to choose 3. So I'm going to show you that in my calculator. You always have to enter how many first. So I'm going to do 18, math, and then I'm going to go over to probability. I'm going to choose option number 2, and then I'm going to choose 3, and I get 4896. So this is 4896 ways to choose officers. Okay? Alrighty. So again, we're going to talk about a combination coming up right away, but when I have a combination, the order isn't important. So you have to be able to choose whether it's a permutation or a combination. Alright, so with that being said, the next thing that we're going to talk about is a combination. Okay, so previously we talked about a permutation, and this was when the order, can you see that? Yeah, the order was important. Now we're going to talk about a combination where the order is not important. And again, I'm just going to show you the formula because I think it's cool to know the formulas. But the combination of n choose r, again, is how many things chosen are ways. Is going to be n factorial over r factorial times n minus r factorial. And again, you're going to be able to use your grapher, so you don't need this, but I think it's always kind of cool to notice. And then if we talk about the notation that this book tends to like to use, we would write it as a combination of n choose r. So now we're just going to jump into our next example, okay? So we're going to do example number 7. Alrighty, in this one, a student has a summer reading list of 8 books. The student must read 5 books before the end of the summer. How many ways can the student read 5 out of the 8 books? So this is a situation where there's no award or reward. You have to read the books, and because you're procrastinating and instead of reading, you're doing some math, math, then we're going to talk about how many ways can I read those books. So this is the combination. There's 8 books total. I have to read 5. And again, the book likes to use the notation 8, 5. And if you push buttons on your calculator, that's going to give you a 56. And let me show you that math. So I'm going to enter again how many things I have. I'm going to do math, and I'm going to go over to probability. Now, if you see option number 3 is the combination. We had to read 5 books, and there's my 56. So that's actually kind of handy. Okay. All right, and then ways to choose books. Okay, so for the next example, example number 8, I have a child that wants to pick 3 pieces of Halloween candy to take in their lunch. How many ways can they choose? There's 13 pieces and they have to choose 3. Sorry, brain and mouth aren't working at the same speed. How many ways can I pull that off? Again, the order is not important. Hopefully we don't think the order is important. And it's going to be the combination of 13 choose 3 or the combination of 13 choose 3. And pushing buttons on my grapher, that's going to be 286. Example number 9. A class consists of 15 men and 12 women. Now, this is actually a unique problem, and I'm going to write that word up there so we know that this is a slightly different example. In how many ways can we choose 2 women and 2 men to be chosen to participate in a class activity? So, again, there's no reward in this one. We're just choosing who's going to get to participate. So the first thing I need to notice is that I'm choosing men and women separately. So the first one is I have the combination. I'll do men first since they come first in the problem. 15 choose 2. And then I'm going to multiply by the combination of 12 choose 2. And again, I can push buttons on my calculator, and I'm going to get 105 times 66. And this is 6,930 ways to choose students. So if I'm procrastinating, and I need to choose which students are going to participate in an activity, I could spend time figuring out the 6,930 different ways that I could pull that off. Okay? So for my next example, now there are 20 students in a class. 12 are women. The names of the students are put into a hat, and 5 names are drawn. Now notice this is because we have a new idea. What is the probability that all of the chosen students are women? Okay, so we're going to set this up. So now we're using our combinations, and we're going to do a probability. So what's the probability of getting all females? Okay, well, the first one that we're going to talk about is the number of ways to pick a woman, and it's going to be divided by the number of ways to pick the 5 students. Okay, so I'm going to set this up with combinations. The number of ways to choose a woman, there are 12 women, and I'm going to choose 5. And then the bottom number is always, remember, your total when we're doing probabilities. So there are 20 students, and I'm going to choose 5. And I can push buttons on my calculator. The first number is 792. The denominator is going to be 15504. And when I do that math, I get 0.051. And then that's going to be 5.1% is equal to the probability that I can pick all women. Okay? Alrighty. I have one more example for us. It was a lot of examples today, which is why I wrote them out ahead of time. So now we're going to play poker. Yeah, cards. In this one, it says a poker hand consists of 2 cards. What is the probability that the poker hand consists of 2 jacks or 2 5s? So we need to do a little bit of math first. So one of the things that I need to remember is this is a mutually exclusive event, meaning that I can't draw jacks and fives. It's not possible because they're two separate things. So then if I want to know how many ways can I draw a jack, then that's going to be the combination of 4 choose 2, right? Because there are 4 jacks in a deck, and I'm only going to have 2 jacks in my hand. That is 6, and I did this in my calculator. How many ways can I get some 5s? So that's going to be the combination of 4 choose 2 again, because there are 5 cards, 5 5s in a deck. I'm going to choose 2 of them, and so that is 6. Okay? So then the next thing that I want to figure out is how many 2-card hands can I get? Well, remember that there are 52 cards in a deck, and I'm going to choose 2, so that's 1326. Now, lastly, I'm going to calculate the probability of getting 2 jacks or 2 5s, okay? So that's going to be 2 jacks or 2 5s. Because it is an or, remember this number was 6 and this number was 6 from here. An or means add, so this is 6 plus 6, and then over my probability of getting these two situations, so drawing 2 cards, this is the total number of ways that I can draw 2 cards. So then my probability is 0.009. So this means that I have, let me scoot my paper up, a 0.9% chance. And I'm just going to say, oops, that's a bummer, because that means that it's not going to happen. All right, my dears, that is it for